Okay, Bismillahirrahmanirrahim. Let us come back to the chapter 5, solving linear first-order differential equations. We will be learning two methods, and we have learned this first method under 5.1. Okay, we solve it by separating the variables, and if you cannot separate the variables, then you have to use method 2, integrating factor. Let us look at more examples on how to solve this. So there is a question given in our workbook. Okay, page 288. Solve the differential equation. Differential equation is when we have an equation within the equation there is the first order derivative. Okay, that's why we call it as linear or first order differential equation. Okay, let's do this together on how to get dy. Okay, so I'm rewriting back the question, okay, given to us the differential equation. Can we use method 1? What was method 1? Are we able to separate the variables? In this case, obviously, it's easy to separate the variables. But yet, when you are separating the variables, make sure that the dy and dx is on the numerator value. Okay, so there we bring the y here and dx over there. So it should be correct, okay, up to that level. Okay, after you have done that, okay, to get the y, integrate both sides. Okay, here we have the integral of 1 on y dy. So integrating 1 on y with respect to dy, we get ln y. And out here, integrating 2 with respect to dx, so we get 2x. Okay, so we get that. But still here, we have a y. So we have ln y, how to get dy? So we need to apply the property of exponent when the property of the log. When we have e power ln y, the value is y. Okay, introduce e both sides first of all, and then this value is y. As for this value, it becomes e power of this thing, and using the law of our exponent last time, if we have, let's say, a power x plus y is actually a power x multiplied by a power y. This was our law of exponent from our high school work, right? So we can change it into multiplication. And here, this is e power c. C is a constant of our integrand. It's a constant. E power c is a constant. We can call this as k. So if I call it k, so that we get dy value, y as k e power 2x. So that is the answer. Okay, we have solved the differential equation. Okay. Next, let us look at example 2 given in our workbook. Can we solve these linear differential equations? Okay, can we separate the variables? This question is a little bit tricky. So first we multiply the x, okay, on all sides. So we get 3y squared y dx and 6x squared dx. Can we separate the variable? Okay, so after that, let's combine the x with the x, y with the y. Can we do that? Here I'm combining dy first. Okay, or here I'm combining dx first. So we have 6x squared minus 3x squared. There is still a y there. Can we separate the x from the y? Okay, if we consider to factorize 3x squared, so here we are left with 2 minus y. Okay, so let's bring this divide by 2 minus y both sides here. So we get 1 over 2 minus y dy. Over here we get 3x squared dx. So meaning these differential equations, okay, we can still solve it by separating the variables. After you have separated nicely like that, okay, the numerator dy is on the numerator part and dx is on the numerator part. Consider to integrate both sides to solve for the y there. So here we have to know on how to solve the integral. Okay, a simple use substitution can be done there, right? So simple use substitution, we simplify this such that dy is negative du, and over here, okay, so we integrate all. So here this is a ln u, negative is there, and here we have 3x cubed over 3, and we simplify, but still you cannot leave your answer in terms of the ln. Okay, what is u there? U was 2 minus 1. Okay, so you need to simplify further to get your answer as a single y only. So you have to introduce e, okay, turn it into exponential function, such that again, okay, by applying the property of a log function, e power ln x is x, okay, log of our log. So here e power ln of this 2 minus y is 2 minus y. There we managed to get rid of the ln. As for the right side, we have e power of this negative x cubed minus c, and then applying the law of exponent. Okay, so this is like e power negative x cubed multiplied by e power negative c. Here this e power negative c is a constant. I can call it a, okay, a constant value that we do not know. We need to have the initial value, okay, to get to that a, some information to solve for the a. So as of this level, you just put the constant. You can call it a big C or a in this case. So you have this. So hence we got the y. So that the y is 2 minus a e power negative x cubed. Okay, you can just write it down like this. Okay, and since that a is a constant, it does not matter either the a here is read as positive or negative. You can also read it as a positive. Okay, because later on we are to solve for our a. So that is our answer, the y value in terms of the x. Okay, let's look at example 3. Okay, another question given in our workbook. Okay, solve the differential equation. This is the first order. Okay, the first derivative is there in the equation. So it's a first order or linear differential equation. So how to get to the y there? Okay, so far we know this method of separating variable. Can we separate the variable y with the y and x with the x? Let's try it. So here I'm trying to separate the x by first multiplying dx on all the terms. So here we have multiplied dx, it remains it as dy, and multiply the second term there with dx, so we have dx, and then the right side we have cosecant x dx. So let's combine the dx, so we have cosecant x minus y. There's a y there. Okay, how to separate the y with the x? Can we separate the y from the x? Okay, even though let's say we take out the 1 over sine, cosecant is 1 on sine, cotangent is cosine on sine. I'm factoring out these 1 over sine. Okay, so we are left with 1 minus, but there is still y over there and combining with the x. Okay, meaning what? Meaning you cannot separate your x and y for this case. So this is where we have to find another method. Okay, we cannot solve this first order differential equation using separating variables. So we need to learn method 2, which is integrating factor.